So as we speak, all you see is the board, my voice. If you speak, you hear your voice, and you just see this. So this is like your virtual classroom. So whenever you're not here, you can go to the video. If you have trouble with an example we did during the day, just hit it at night and go to the video, and I'll hook you up to Edmodo so you can have better access to it. Okay, so let's take a look at these. Now remember, there's a difference between discrete and continuous. A discrete set is just a set of ordered pairs. If this is a function, then the x's cannot repeat. Every x has one and only one y value. Inverses, we'll get to it another time with a one-to-one, but inverses we'll do separately. Domain, everybody okay with these? Can you see them? They're a little light. Okay. Again, pull out your domain. If the x repeats or the y repeats, just put it once. Which relationships are functions? You have the first and the third. The second one, the 13 repeats. Just eyeball it. If you were to graph this and you did okay. Let's not use blue. Maybe the blue is giving me grief. So if you did 13-4 and then you 13-5 and then 13-14, that's where it fails your vertical line test. Relations number 1, number 3. God bless you. Just number 2 is a function. Stop me if you have any questions. If you didn't get it, stop me. Otherwise, I'll just keep going. Which function, for this to be a function, x cannot be? It cannot be any one of the x's that you just used. Any one of those x's, it cannot be. Okay. Again, domain and range, interval notation. Okay. Number 8, and I keep picking up the blue is not good today. If you go like this, now remember, you read the x's left to right. You read the y's bottom to top. So when I come up to here, I haven't used any of those negatives until I hit here. So -3 is the first one I'm going to use. It's my vertex, my turning point. So
Good morning. Today is Monday, September 11th, and it is a B day. All classes should be at level 0 at this time. Will everyone please stand for the pledge?
Okay, please rise, guys.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for a moment of silence. Today, we remember the nearly 3,000 lives lost on September 11, 2001, after attacks on the World Trade Center, the Pentagon, and a plane crash in Pennsylvania. We also would like to keep the state of Texas and Florida in our thoughts. We can have a moment of silence at this time. Thank you. Please be seated. Good morning. We have several announcements before we begin the day. Congratulations to the Marathon Project at the second annual Color Run. NFA had 5 first-place finishes. Mrs. Listowski, Mrs. and Mr. Truez, and 3 awesome students from NFA Maine and NFA North. Congratulations to the Marathon Project. Attention seniors, application for parking spaces are available in your assistant principal's office. We will be accepting applications until Friday, September 15th. If you are approved, parking passes will be available for pickup on Monday, September 18th. And as a reminder, seniors, you are only allowed to park in the blue and gold student section. You will be towed if you are parked anywhere else. The NFA debate team is hosting our annual Pink Day in honor of breast cancer awareness on Friday, September 15th. We are asking all students to wear pink to school that day. We're also asking that you attend the night's varsity football game on Academy Field. Tickets will be on sale. You must have a ticket in order to enter the game. Tickets will not be sold at the event. Make sure you pick up your tickets before Friday. And tickets will go on sale in your assistant principal's office. There will be an indoor boys track team informational meeting on Thursday, September 14th at 2:30 outside on the bleachers by the track near the finish line here at NFA Maine. To faculty and staff, please sign up for the following committees in Mr. Cruz's office. DASA meets the first Thursday of the month. Health and Safety meets the second Monday of the month. Emergency Response Team meets the first Tuesday of the month. JV cheerleading tryouts will be held today and tomorrow from 4:30 to 6:30 at Fostertown Elementary School. You must bring a yellow form in order to participate. Also, you must bring both the yellow slip and sneakers. Be prepared to work out. The sept team will hold an informational meeting Wednesday, September 13th in room 133 at 2:30. Please see Mrs. Caldera if you have any questions. Student council petitions for the freshman class will be available on Monday in all AP offices. Reminder students that 5 and 5 will continue. The bathrooms will be closed 5 minutes before the bell rings and reopen 5 minutes after the bell. IDs should be picked up if you have not done so already in your AP offices. And that is all for today's.
We're almost done with this. Okay. Domain again, this is very similar to the one before it, except what kind of graph is this? Absolute values. Okay, so can anybody give me the equation for this absolute value graph? I'll start you off. Not -2. Alright, did you come up with something? I'm on. You both at the back on me. Minus what? -3. Okay, transformations. You guys did transformations, right? Algebra 1 and geometry? Last year my kids were good, real good in transformations. Previously, before Common Core, not as good. But Common Core does a nice job with transformations. Okay, domain. I can put any x here that I want and get myself a y. What I can't do is I only get one y. So, just the 3. Okay. This is a discrete set. It looks just like the set of numbers on your first page. So if you need to, write the points out or just pull out the x's and pull out the y's. 12, I think this is the only one that wasn't a function. A circle fails a vertical line test. Box this off. If you struggle with finding where your domain and your range is, your domain goes from here to here, 2 to -2. Your range goes from -2 to 2. Your range goes from -2 to 2. Start getting used to function notation, to integral notation. That'll start getting easier. All right. I can't wait till we get these new boards. If we get them. Okay. This is a function. Because when I put a vertical line down, one point is open, one point is closed. So therefore, that gives me a function. And it goes here too. My domain, at any x, I have some kind of a y out here. So my domain is real numbers. My range, if you see where this is going, this line from here goes on and on. This line goes out here, not a big deal, but this kind of covers that. The only little space I need is right here. So there's nothing higher than that one right there. So it's going to go from -infinity to 3. Soft graph. Good. And the last one, I think this is your last one, right? Your last one, we're going to see a little bit of pretty soon where it jumps over here. Your domain says you can use all of this to here, to 1. Then you're going to have a little gap where you can't use. You're going to start again here, but you can't exactly use that one. So this, while this -1 has a hard bracket, this +1 has a soft bracket. and you've only got two numbers for your range, a -2 and a +2.
Why is the range in curly brackets?
Because if I did this, then it looks like my range goes from -2 to +2, right? Interval notation and set notation are two different things. And if I did this, it would almost look like, even though your interval notation also looks like an ordered pair sometimes, this is set notation. Like when we did the 3 with the hard bracket, you could have done it like this as well. Just put it inside a set bracket, because that's all that was there. But since it was only one, we could also put it in with a hard bracket. Okay. That's a good question, because they're kind of different when you work the brackets. Are we okay with this? 3 most important domain restrictions that we need to worry about. What do I mean by a domain restriction? Things X can't be. We got 2. Did you guys not get 2? We didn't get enough. Of which one? Which one are you guys missing? Got it? 9 times out of 10, it's my fault. Okay. Things X can't be. Give me an example. An imaginary, but we're not going to worry about imaginaries. X could be a whole number. X could be 0 sometimes. When can X not be 0? If X is where? In the denominator. So that's one domain restriction. So if X is 0 here, I can't use this, right? Because we cannot divide by 0. So therefore, you have to take your domain restrictions out of your allowable domain. I don't know what is going on here. Give me a minute, guys. I don't know what happened. All right, you're going to take your... Oh my gosh. I told you I have a haunted board. It does this to me on purpose. Okay, let's see if I can try this one. All right, I'm doing black. Okay, here's the problem. I can't use a 0. When I graph this guy, and you're going to get graphing calculators, and I put this into my y equal, and I do 1 divided by x, and I go to graph this, I have a little problem. Something causes this to break away, which is that x is equal to 0, right? I can't use x is equal to 0. Did you guys learn the word asymptote? Yeah. Okay, so this creates an asymptote. Things in the denominator I can't avoid. So therefore, it's going to say stop, and it's going to change the behavior where my graph is going. We call that end behavior. So this is one of those conditions. Now normally, for this guy, I would say use all real numbers. But now I can't use the 0. So my domain says you can use anything up to the 0, jump over it, and continue again. This is my domain, my restricted domain. I took out the things or the thing that I couldn't use. Yes? I took out what I couldn't use. Now, this is going to be the same thing. There's a denominator. I cannot, all that I know is I cannot have a 0 in my denominator. I can have a fraction, I can have a negative number, I can have an irrational number, but I cannot have a 0. My first restriction. So I take this and I set this equal to 0. Now, either I can factor it, my perfect squares, or I can just move the 4 over and solve for x. Take the square root. Remember, when you take the square root, you always get a plus or minus. So I know that x cannot be plus or minus 2. So I say, okay, here's my domain. I'm not allowed to use a -2. I'm not allowed to use a +2. But I can use everything else. Right? I don't care if it's a negative. I don't care if it's an irrational number. I don't care if it's a decimal fraction. I just can't have it equal to 0 because I cannot divide by 0. So I take my domain out, these -2 and +2 out of my domain. So I go from -infinity to -2. I jump over -2. I have to go in between here as well. I go from -2 to 2. I jump over that, and then I go from 2 to infinity. Okay, so I take out the things that I can't use.
So what's after the first one? -2.
As I come from left to right, I can use all this, God bless you. So I can come here, I gotta stop at -2. Remember, I can't use -2, stress bracket. Then I say, okay, get over this thing. Then I can use all in here. So at my second group from -2 to 2. Then I jump over 2 because I can't use that. And I go from 2 to infinity. This is my restricted domain. This is the domain that I am allowed to use. I have some restrictions in there. Some things that I cannot use. These are the things that it's going to throw me off on, and so I'm going to have to remove them from my real numbers and be able to use them. Make sense? So you're going to set your denominator equal to 0. You're going to find out where those bad boys are and take them out of your real numbers. Okay. There's only 3 of these things you have to worry about. The second one is under a radical. What can I not have under a radical in my real numbers? A negative. Can I have 0? What's the square root of 0? 0. What's the square root of 1? 1. But I cannot have a negative. So for a radical, we do it this way. We say, take whatever underneath the radical sign and set it greater than or equal to 0. And solve for x. This is the numbers I'm allowed to use under there. So x is all by itself here. So I can use 0, 1, 2, 3, 4, 1.2979. I can use anything greater than 0, and I can use 0 in this. So my restricted domain is 0 to infinity. Anything I put in there, I can put in a 3, a 3.729. I can put in anything I like. I will still get another answer in the real number system, but I cannot put a negative number in there. We leave our imaginaries for one little portion somewhere down the line when we get to quadratics, but everything else we work in real numbers. So I apply the same thing here. There's numbers that I'm not going to be able to use in here. So I apply same rule. Take x plus 3 and set it greater than or equal to 0. It just cannot be negative. On my number line, here's my 0. I can use these numbers. I can't use these. So therefore, set it greater than or equal to 0. I subtract 3. Now x is greater than or equal to -3. So my restricted domain tells me, okay, from -3 to infinity, you can use in here. Doesn't have to be a perfect square. Doesn't have to be a rational number. It can be irrational. Okay. So on my number line, from -3 all the way up here, if I stick a -3 in here, -3 plus 3, 0. If I stick a -4 in here, -4 plus 3, -1. Can't use it. So for radicals, we're going to take what's underneath the radical sign. We're going to set it greater than or equal to 0. And we're going to automatically come up with our allowable domain. Make sense? Okay. Lastly, we're combining these two. We have a problem with the radical. We have a problem with a denominator. So we must have a problem if we put this radical in the denominator. Same way we do up here, but we say, okay, it's got a problem with the radical. It can't be negative, but it also has a problem in the denominator. it cannot be 0. So now we're just going to set it greater than 0. I can't use 0 this time. So my domain, therefore, would be 0 soft bracket to infinity. I can use 0.0000001, but I can't use 0. So if I were to graph this, my board is the most unplugged board ever. If I was to graph this guy, and I graphed it like this, I would say, okay, here's my graph. It's a piece of a graph because it's a radical and it's a denominator. If I looked at my table, I'd have all errors, all in here, all my negatives, and my 0 would have an error. Okay?
No.
Okay.
Yeah.
And my 0 would also have an error. This is a nice way to match up your, holy smokes. Okay. All right. So let's apply the same rule here. We still have a radical. We cannot be negative, but we also have a denominator. We cannot be 0. So we take x plus 3 greater than 0. We subtract 3. And x is greater than negative 3. So negative 3 just gets a soft bracket. See the difference from here to here? The only difference is that denominator causing me not to be able to make it equal to 0. So whatever number makes it equal to 0, I got to get rid of. I can use to the right of it, but I can't use that number. These are the only 3 restrictions we're going to deal with this whole year.
So maybe x plus 3 is greater than 1 or greater than or equal to 1?
Right. Greater than 0, because what happens is if I put a 3 in here, if I put a negative 3 in here, because if this guy had, say, I could use a negative 3, my rule of radical works okay, but now my denominator says, whoops, can't divide by 0. So I have one rule where a denominator cannot be 0, one rule where a radical cannot be negative, and I combine those two, a radical and a denominator. So same rules for both combined. So it cannot be 0 and it cannot be negative. Okay? Now, as simple as this looks, this is always the tricky part. The radicals, we build the domain as we set them equal greater than or equal to 0, as we set them greater than 0. The one with the equal sign, we have to figure out ourselves. We just have to set it equal to 0 and see what happens. Now, when in doubt, put this in your calculator, graph it, see where your errors are. When I put this in my calculator, I notice all those errors up there. I notice those, can't use those. This one would be a little trickier because it's going to stop me and show me negative 3, and I'm going to see the difference between this one and this one. So look in your calculator as well so that you can see where your domain restrictions are. So these are called restricted domains. Normally I say all real numbers, but whoops, we got a little bit of a condition here. So really, those 3 cover everything. And we're going to come back to these 3 forever.